Today's topic is going to be very interesting. Basically, we talk about the three kinds of copies you can do for your iPhone code. Of course, it applies to Java code as well. So we talk about reference copy, we talk about shallow copy, and we talk about deep copy. And now today, the main goal is to use these three kinds of copy in a way that can help you write complete postcondition. That's the ultimate goal, which we'll get into today for sure. But we're going to continue to finish the example that we started with. And let me remind you what we did last time. Okay? So this is a very simple setup we are having. Okay? Basically, we got two arrays over here. And we got old imp, the old copy of the implementation. And also we got imp over here. Basically just two variables over here, old imp and imp, both array of string. What we want to see is, we want to really copy the old imp from the imp in a way that may or may not be affected by any changes we're going to make. Okay? That's kind of the roadmap. We're going to see that by this example, and then we'll move on to how things will be done automatically for the contract checking at the runtime by iPhone for you. That's something we're going to see. That's why we're going to build out the basics for you to understand. Okay, anyway, for this one here, let's review again. We're going to present many versions. We're going to present three versions of code, or three or four, I forgot. We're going to present multiple versions of the code. We're going to see exactly just making a difference, making a change on the way we make copy can make difference. Okay, but let's review the very first version just as a recap. Okay, you can see the very first version here in line number 2 over here. The way we copy to old imp from the imp is by, let me do it again. The way we do the copy to old imp from imp is by doing a reference copy. Okay, that's exactly, you see the copy over here, just reference copy. Okay, just copying the reference basically. And then we simply, you can see that the aliasing effect is make sure they are pointing to the same objects, right? So that means we got old imp over here that is pointing to just the same copy of the array. Okay? Without going to too much detail, what I want to show you is this particular loop, across loop. It's basically corresponding to some universal quantification. We're basically going over from 1, let's assume the indices of the array start with 1, the iPhone convention. And then from 1 until the last index, we're making sure all the elements have stayed the same. That's basically what we are checking here. Okay? So now, as you can see over here, we got imp, and also we got old imp. In this particular setup, when we reach line number 6 for every iteration, apparently we got 1, 2, and 3. We got 3 strings over here to look through, right? We got 3 iterations in total. And then, now, this is something we discussed last time, but let's do just very quickly. Apparently, you can see that j.item is going to be of 1, and 2, and 3, right? Because we got 1, 2, and 3. 3 elements in the array over here. Now, just take the first one. For the very first iteration, this is what we're going to check. We're going to say imp add position j.item will just be 1. Tilde, which means is equal to old imp, and over here, j.item. If you try to look at that, you're really comparing two things that are really referring to the same structure, right? You can see imp is pointing to this particular object, and you're going to position 1, which is referring to this object over here. At the same time, when you say old imp, which we did a reference copy over here, it's also pointing to the same array objects. So when you say old imp at position 1 over here, it's also referring to the same string objects, right? So now this loop we can assume, we can actually expect is going to return true. Okay, any question up to now? Right? That's like a recap, yes. Which symbol? The tilde here? Okay, tilde, I can talk about it briefly a little bit later, but tilde simply means like it's equal. You're comparing the contents of two things. Yeah, right. Okay, so one more thing to show you over here. You want to really pay attention to what kind of changes we are making over here. You can see that here we simply say imp at position 2. Imp at position 2. We are changing that to a new string called Jim. So that means position 2 over here, rather than pointing to the original string, which is Mark, it is now pointing to a new string over here, which is Jim. Right? That's what we have over here. Even after the change, can we actually see that this across loop will still return true, right? Because we know that every element that we're referring to is just the same by old imp and imp. So after the change, if you look at specifically, let's say old imp at position 2 versus imp at position 2. You can see that over here, they are really referring to the same string over here, just Jin. So there's no difference over here, just referring to the same thing. Of course, when you try to do tilde, it's simply just going to be true. In fact, if you use the strongest equality over here, rather than saying tilde, even if you say equals, which means you compare the references, they will still be just true. Okay? That's a very important thing to notice, even though the first example is easy. Okay? Now we'll make things a little bit more complicated. Okay? Guys, any questions until now? It's more like a recap to bring you up to speed. Okay? So what we will do is we're going to make the following change in the next version. We're going to say rather than making a reference copy over here, what about we make a shallow copy? Okay? Let's say this. Next page over here. The only thing I changed was I simply say rather than just reference copy, now I say imp.twin, which means it's a shallow copy over here, right? Shallow copy means I'm going to make a new array objects only at the first level. However, starting from the second level, every object from the second level is going to be copied again by reference. That's a definition for a shallow copy, right? Now, very quick, I'm going to illustrate to you for sure. Let's say we are still doing the same change over here, okay? Just say imp2 is assigned to Jin. Is this going to affect imp1? Oh, sorry. Okay, the question is, what about old imp2? Is it affected or not? That's the question. Okay, if you're not so sure, that means you might need some picture to help you. Okay, the question is very easy. I'm asking after line number 3, after I reassign imp at position 2 to a new string, is it going to reassign old imp at position 2 at the same time? That's my question. Take a guess, yes or no? Yeah, okay, we got both sides. Okay, we'll prove one side is wrong. Okay, cannot be both true, right? Okay, and then after that, we're going to say from line number 4 to line number 7, the same across check. Oh, actually, I already give you the answer. This is going to be false this time, which means there's really a difference between the old imp and imp this time after that change. But let's see exactly why. Okay, it's really important. So what I will do is, let's make a shallow copy. Let's say we got old imp over here. So I'll say old imp. So what's the consequence of doing this imp.twin? That means old imp is going to point to just a new array objects, okay? Array of string. And then it's going to contain, again, 3 slots, right? That's at the first level. But now, starting from the second level, we're only going to make reference copy to the objects, which means old imp at position 1, okay, for example, old imp at position 1 is just going to be assigned to imp at position 1. Okay, that's implicitly done for the shallow copy, something like this. So old imp at position 1 is just going to point to this particular new string over here, right? Shallow copy. Similarly, old imp at position 2 is going to point to the second string over here. And old imp at position 3 is going to point to this string over here. That's a shallow copy. Guys, are we okay? Which means only make a new object at the first level. Starting from the second level, you just do reference copy. That's the definition for shallow copy. So now, let's try to go back to this particular line of change, which is really important. Okay? So now, I'm going to highlight it in blue over here. So what does this change over here mean? When I say imp at position 2 is reassigned to a new string, let's do that. Okay, I'm going to use red. So now imp is basically over here. Imp is pointing to this particular object, which is a different object from the shallow copy. And then at position 2 over here, we're saying that it's going to reassign to a new string, which is Jin. So that means rather than pointing to over here, it is going to point to a new string over here, and then I'm going to put Jin over here. Okay? So far so good? So now, when I was doing this particular reassignment, am I changing old imp at position 2? Well, old imp at position 2 basically is over here, right? I wasn't really changing that, was I? Right? More importantly, let's say after this line, after line number 3, if I try to do the following comparison, if I say old imp at position 2, let's say equal sign, just say equal, okay? Equal imp at position 2. Is it going to be true or false? False, right? Because over here, you can see that over here, old imp at position 2 is really talking about this particular object over here, mark. And imp 2 is talking about this new object. Of course, they are different, okay? Which means the change we just made can be distinguished between shallow copy, okay? Now, that is why when you're trying to run this particular cross check over here, we know that for the very first iteration, we're basically still comparing Alan and Alan. But for the second iteration, when we get to 2 and 2, index 2, right? We're basically comparing this object over here and this object here is going to return false, right? When we do the tilde, because you simply compare Jin versus Mark, so they are different strings. Okay, so for the very first iteration, it's going to be true. We're just comparing Alan with Alan. For the second iteration, it's going to be false because we're comparing Mark versus Jin, right? And then for the third iteration, still Tom versus Tom. But now all over here is going to be all the iteration must be true. So you got true, false, and true. That'll give you false. Okay, that's for universal quantification. Guys, are we okay with this? If you find it going too fast, just tell me, okay? Any questions? Yes, go ahead. Yes. You mean the tilde over here? Yes, good question. I would say over here, for the tilde here, you can think of it, it depends. It works a little bit like an equals method in Java. You know, in Java, if you have not redefined or overridden the equals method, it's going to compare references. If you have overridden it, it's going to compare contents. Let's say here, you simply just compare the string using tilde. That means it's going to compare contents. Okay? Okay, guys, any question about this particular version over here? Okay, I have a question for you. Apparently, when I was trying to make some change at the second level, at the first level, I was just simply reassigning imp at position 2. And this can be, this change can be actually told just from the across loop over there. Can you suggest a change over here instead? What I mean is this. You can see this, I want you to focus on this particular line here. Imp 2 is reassigned to Jim. Can there be another kind of change such that the loop over here is not going to return to me false? It will still be just true. What kind of change can you make? Apparently, if you're only doing reassignments over here, it's not going to work because we can easily tell between the two copies. What kind of change can we make so that it cannot be distinguished? Yes?
I'm not entirely sure exactly what the function call would be, but there has to be a way to somehow instead point at the string reference itself and change that string's
in particular. For example, you can append to that string some junk, for example, right? Basically, what you're suggesting is rather than reassigning the objects at the first level, we want to make some change beyond the first level. And that one is going to be beyond the capacity of the shallow copy, because beyond the second level, everything is a reference copy for shallow copy. Okay, let me illustrate it to you. Okay, anyway, for this particular version here, for the shallow copy, we are saying that if you're only trying to do some reassignments at the first level, it just cannot be told. Okay? It just cannot be distinguished. Now, let's go to the next version here. Okay? We do have shallow copies still, but now, as what you suggested, that's exactly what I was expecting. So now, if you look at line number 3 over here, what are we doing here? We're basically saying we still want to change imp2, but the kind of change we're doing is to say rather than just reassigning it, we are modifying that object directly. Okay? Now, think about how you will visualize this change over here, okay? So now, okay, of course, I give you the answer already, it's true, okay? If you try to do this kind of change over here, running the same across loop is actually going to give you true, okay? That's the interesting thing, which means, well, it seems like there's certain change that just cannot be distinguished on the shallow copy, okay? Let's see. Again, let's do a shallow copy very quickly. Let's say we still got our old imp over here, and it's pointing to a new array objects over here, so it's array of string, shallow copy. And then we have our three elements here. Okay, the first element, again, is a is a reference copy beyond the first level. Okay, over here, let me try to make it a little bit not so messy here. Okay, and then over here, it's pointing to this particular object, right? So now, let's look at the line and see how the change can be visualized. If you look at this line here, line number 3. So what does it really do? Okay, basically what it does is like this. Go to the objects being pointed to by position 2 of the imp array. Imp array is over here, this is position 2. So we are talking about this particular string over here, and this is a command, which means we don't return anything, just modify that string directly. So what do? We simply append star, star, star to the end. That means rather than, let me just use a different color. Rather than mark over here, it's now going to be mark, star, star, and star. And no new object has been created really. Okay, the same. So now the same question for you. Okay, remember in the previous version I asked you, after line number 3, old imp at position 2 equals imp at position 2. From the previous version, we know that it was false because you simply reassign to a new string, right? Let's do the same comparison. Now, if I say after line number 3, if I try imp at position 2 equals, well, I'm comparing the reference. Are they referring to the same objects? At position 2. Now, are they going to be true? Is it going to be true or false? True, right? Because you can see old imp at position 2 is referring to this particular string, which is mark star star star. And also for imp at position 2 is also referring to the same modified string. Okay, so it's just going to be true. So that means if you're trying to modify your object structure beyond the first level, the shallow copy just cannot really tell you this is really a change. Okay? Okay, this is really the reason I talk about the serious differences. Okay? Okay, so we know that it's just going to be true because now all the iterations for the across all loop, you're just going to compare the same string for all the 3 iterations. Okay? So it's going to be true. Yes? The tilde is basically, yeah, so it's going to check the contents, right? But, you know, in this case, even the reference, the strongest comparison will give you true. Not to mention the contents will give you true, right? If you're referring to the same objects, it implies the contents must be the same, right? I'm just trying to show you, in this case, it's really aliasing, right? Yeah. Good. Okay, so now let's go on to, okay, so now for the shallow copy, we talk about 2 versions. Let me just recap. For the first version, we talk about making a change at the first level, just reassigning the objects. In that case, you can see the difference between the shallow copy and the original copy. On the other hand, if you try to do some change beyond the first level, it's going to be different. You just cannot tell the difference between the shallow copy and the original copy. Okay? Now, what we really want to do is to see how making a deep copy can actually show you there's really a change for both cases. Okay? That's why we're introducing the 3 notions of copies. And then we'll move on to see how these things will be applied at the runtime contract checking. Okay? That's why we are presenting this way. Now, let's go to deep copy. Okay? The same 2 versions for deep copy. So now, let's have a quick look. Deep copy is actually go to the other extreme. In the case of reference copy, that's only just making an alias, right, for the top level. Okay? But now for the deep copy, you're basically duplicating the object structure. Okay? So now we have deep twin over here. Okay? Let's see exactly what's going to happen here. Okay? So now for the first change, we simply say imp at position 2 is reassigned to Jin. This actually return false. In the case of shallow copy, we want to see if that's still going to return false. Okay? So now let's see that. How do we draw that? First of all, for the deep copy, I'm still going to make a new object for the array. Okay, so oimp, and then it's going to be an array of string, and also 3 over here. Okay, the first step is just the same as shallow copy. Now, what do I do beyond the first level? I should do the deep copy recursively, right? Okay, there's no reference copy whatsoever in the case of the deep copy. So that means what I need to do is I'm going to have a new string over here, and a new string over here, and also a new string over here. And just one will be Alan, another one will be Mark, and another one will be Tom. And then point to there. Okay, you can see they're completely independent. That's deep copy. Okay? So now, hopefully, it's quite easy for you to visualize to see what's going to happen. Okay? Let's see exactly. Okay? So now, if you try to look at that, let's say for this particular change, if I say imp at position 2, imp at position 2 is now reassigned to Jin. Reassigned to Jin. Now, if I do that, you can see that old imp at position 2 versus imp at position 2, they are referring to different objects. Agree? Okay? We're comparing this object here versus this object here. Of course, they're different, just from the visualization over here. That is why, if you try to do this particular across all, you're just going to return false. And the false comes from the second iteration, right? Let me just write it down for you. So after this line here, when you try to say imp at position 2, if you say equals old imp at position 2, it's just going to return false. Okay? Are we okay so far? Yes. Sorry, say it again. You mean the tilde? Yeah, you know, the reason is I want to show you that in this case, it's simply they're just not the same reference, just different string. That's what I'm trying to show you. Of course. Okay. Of course. Let's say this. If you say imp2 and old imp2, if you simply use a single equal, okay, first of all, they're different objects, so we know that it's going to be false. Yes, you can definitely say, if you say imp2, let's say, by the way, you can do this syntax here. You can say / not, and then tilde. That means not equal to, okay? And then you can say old imp2 over here. So now we are really comparing the contents of the two strings. Are the contents the same? No. One is Mark, the other one is Jim. They're simply not the same, right? That's also going to give you false. Yes, both cases.
So what if, let's say, we didn't do that into Jim, and it still points to 1. If you hello, what will happen?
If you're asking a hypothetical question here. Are you asking to say if I don't have this line over here? Okay, let's say we don't have it. Okay, so that means array. I'm gonna undo this. Okay, okay. Let's say we don't have this line. That means imp at position 2 is still pointing to Mark. Let's say. Okay, you're asking what's gonna be the comparison result, right? If I say imp at position 2 equals old imp at position, it's a good question. Versus imp at position 2 tilde, which means you're going to compare the contents. Old imp at position 2. Okay, let's say this is 1, this is 2. What's going to be the result for 1? False, right? Because we're talking about this object here versus this object here. They're simply different objects. On the other hand, for the second one, true, right? Because we talk about basically M-A-R-K. He's M-A-R-K as well. Good question. Actually, I like that. Good. Yeah, that will complete the picture. Guys, are we okay? Good. Okay. Now, let's go on to the last one. Okay. This is actually the change that could not be distinguished with both the reference copy and the shallow copy. Now, we want to see if that can be distinguished by deep copy. Right? First of all, the answer is yes, because you will see false over here. That means from the deep copy point of view, the two object structure will be considered as different after this change over here. Let's visualize that. So I have deep twin over here. Let's draw that very quickly. So I still have my old imp over here. pointing to a new array of string. And then I'm just pointing to individual string over here, okay? Completely independent object structure. I have Alan over here, I have Mark over here, and I have Tom over here. Okay, that's deep copy. Now, if I try to do this particular line number 3, now, which string object am I modifying really, right? You can see that imp at position 2 is referring to this particular string over here, and then I'm appending star, star, star to it. So that means rather than Mark over here, it's going to be Mark, star, star, star. Okay? Now, if I try to run this particular check over here using the for all, right? It's going to give me false, right? Which iteration though? Second, right? Let's try to run that very quickly. For the very first iteration, we're basically comparing tilde, right? It's comparing not reference, but contents. We're comparing the string Alan with the string Alan. They are the same string, well, contents-wise. In the second iteration, we are basically comparing Mark versus Mark star, star, star. And that's going to give us false, right? In the third iteration, we're going to have Tom and Tom. In that case, it's going to give us true. So you got true, false, and true. You still get false eventually, right? Okay? Okay, hopefully that makes sense. True, false, and true. Eventually, you still get false. That's why you get false over here. Okay. So in total, we talk about basically one case for reference copy, 2 cases for shallow copy, and 2 cases for deep copy. Okay? Make sure you really understand what's going on over here, right? First of all, you want to know how the each copy is done, and also what can be the change that can be distinguished for each copy. Okay? That's something you want to review. Okay, we will see very soon why we are doing all this, just to prepare you well to understand the postcondition for decide by contracts. It's really important. Okay? There's a reason. Any questions before I move on? Okay. That's good. Okay, so now what I will do is, let me just go through a little bit of slides. Okay, so we have done all the versions over here. Okay, everything's been set. You can also look at the diagram. Okay, the same diagram as I drew. Okay, deep copy, and then, okay, now we're going to talk about how the contracts are checked at the runtime. And for this one, I'll definitely refer you to the state diagram that we talked about previously. But now, I want to talk a little bit more specialized version for the runtime contract checking. This is what I want to draw your attention to, especially post-condition. Okay, this is the simplest illustration I can make over here. Okay, but we'll get to something that's more complicated. The principle is really important. Okay, so now let's say we talk about contract view for your feature. Can be command or can be query. Okay, let's say we have a feature called F, and we have the precondition over here. We got a postcondition over here, and also we got something implementation inside, right? Just very general structure. Now let's say within the ensure clause, let's say you have somehow you use the O keyword somehow. Whenever you use the O keyword and then followed by the O keyword, you have some expression over here. It can be O balance, or it can be O current, it can be O current.deep twin, whatever expression you write. Okay? But I'm going to talk about exactly how things will work in different cases. Okay, so this is the contract view. You might use O expression as long as it makes sense. Okay? So now let's see what the consequence is at the runtime. So now the red one is about the runtime, how the O keyword is going to be used by IFO. Okay? Remember, in the case of the Java example over there, if you want to actually get an O copy of the balance, you have to explicitly write a line in the beginning of your method implementation and then store that value and then compare that at the end. But now everything will be done in a similar way, but automatically by IFO. Let's see exactly. Okay, let's just walk with you the process, and then we'll see. Okay, at the runtime, so this diagram over here is kind of consistent with what I showed to you before. It's a little bit more specialized version, especially these 2 steps that are not so much mentioned in the previous diagram, but that's really important to see. Okay, here's the workflow. Okay, every time you try to execute a feature, okay, first of all, you call the feature, And then you check the precondition. If the precondition isn't satisfied, we go to precondition violation, right? If the precondition is satisfied now, here's a critical thing, okay? I say it's gonna cache all the O expressions. Okay, let me just explain to you conceptually what's gonna happen over here. IFO compiler is going to look at, for this particular feature you're calling, what kind of O expression you're using. Whenever you use O expression, that means their value should be somehow stored now before the feature is executed so that they can be compared against the new copies of the value in the actual post-condition check. So what do I mean? So now let me just give you a very simple example. If I say old balance over here, for example, right? Let's say we're using a bank account class. Let's say withdraw. I say old balance here. IFO compiler is going to say, oh, you're using the O keyword here, and following by the O is a balance, which means we should really try to store the value for this particular expression, in this case, an attribute call. Store the value for that expression there before you try to call the body of the implementation. So that means in this stage over here, for example, if you see O balance implicitly under the hood, this is what's going to be done. IFO is going to say, have some variable, let's say just call it old underscore balance. Okay? Let's say that's a naming convention. It's assigned to just whatever expression it is. Just like that. So this is, I call a caching process. We store whatever that's going to be used in order to check the post condition later. Okay? And then after this, we're going to actually, after we have cached all the variables in the O expressions, we're going to execute the implementation of F. So now that means the balance may have been changed in a way. But that's okay, because the O copy has been cached in this particular variable. So now, when you try to execute the post condition over here, then what's the post condition of F? Okay, let me just make it a little bit more complete for you. So let's say for this particular ensure, if we got old balance is assigned to, actually, let me just put it this way. Let's say balance is equals O balance minus some amount over here. Let's say that's what we have, right? How do we now check this particular post condition over here? Apparently, you can see the balance over here without the O keyword is referring to the new value. That one's easy. Just go there and get the attribute value at the moment. And what about this part over here? Well, to check this part, refer to where you actually did the cache process because it's there, right? And now we can compare these two without any trouble, okay? That's how we check the post condition of F. The process is very similar to how we did a Java coding. The difference is, in the case of Java, you have to do this process manually. In the case of IFO, all you have to do as a designer, you just have to, first of all, you got to understand how the variables will be cached before the body is executed, and also how to write the O expression in your post condition. And the rest, we just handle for you automatically. It's only conceptually, right? But we're going to see examples, okay? And of course, for example, over here, when you, let's say, for the O expression over here, there are many, many creative ways you can write. You have to make sure you know what you're doing, okay? Any question just at this level here, okay? All you have to make sure you understand is, before you try to execute the implementation of the feature, you have to cache all the expressions that's associated with the O keyword from the ensure, okay? So now, let's go a little bit further, okay? So this part over here is pretty much like what I just said, okay? You can just refer to them. And this part here. And now I'm gonna give you some flavor about how you may write O expression. The way you write the O expression is gonna trigger different ways of caching the value in the pre-states, okay? Now, let's see comparison over here, right? So now I got 5 different O expressions for you. Let's discuss each one of them, okay? And then let's see this. For example, the first one is easy. You can see the O keyword is over here, and then we simply say O balance is equal to balance minus A. In this case, we know that the balance is associated with the O. Oh, sorry about that. Thank you. Okay, it's okay. We talked about this example already. Didn't miss too much. Okay, so now for this one here, O balance is equal to balance minus A. So in this case, how do we cache at the runtime before the implementation executed? You got something like this. You simply got old balance implicitly. So this is some variable that's maintained by IFO runtime. Okay, it's simply assigned to the balance. Okay, let me visualize a little bit further. Whatever you put associated with the old, it's just going to be cached verbatim. Okay, it's always patched using an assignments. Okay, let's do a little bit more exercise, and that will show you. Okay, so now let's look at number two. Number two. So now for this particular one, let's say we are now in the context of maybe some bank class, and the accounts is simply just, how about this? Let's say we in the bank class, and the accounts is simply an array that is pointing to an array of accounts, right? Okay, hopefully that's still visible, yes. Okay, and each one of them is simply just it's just pointing to some account objects, and one of the fields is simply just called ID. Okay, let's make the assumption there. Okay, that's kind of runtime structure. Now, if you look at this particular one, so now, what value is being cached? The ID, right? Okay, let's see this. Because I can tell you that the best way to understand your own expression is to see how the parenthesis is grouped. Okay, there's no parenthesis over here, which means this part over here is going to be cached. This whole expression is associated with the old, which means before the implementation is executed, IFO runtime will try to evaluate this entire expression over here and make a copy of that, just a copy of the string. So that means it will be something like this. Like you say old accounts I and the ID. Okay, again, that's just a local variable that IFO maintain. It's assigned to just exactly this expression over here, accounts at position I dot ID. Okay, again, so this is exactly what's going to be cached using assignments. Guys, are we okay so far? Yes.
Are we assuming those are expanded types?
I think, good question. So here, it can be either reference type or expanded type, yes. You can think about at the runtime, they always do the copy over here using call and equal assignments. So now it depends on what the type is for the right-hand side. If it is, okay, let's say this, for example. Let's say the ID over here. If the ID happens to be a reference type, in this case, we're only just doing a reference copy, agree? Okay. If ID happens to be expanded type, that means we're copying the contents, right? Again, the assignment depends on what the context is on the right-hand side. Yeah, good question.
But even if it's a reference type, the caching is going to use a reference.
Yeah, exactly. So you can think about what IFO does. It's very simple. Here's even how you implement that if you want to implement IFO compiler. They simply just do an assignment over here, and then whatever that appears after the old expression, simply copy that verbatim. So now, whether to do a shallow copy, reference copy, or deep copy is completely up to you. For example, it will make a huge difference if you say something like this. Let me just explain that right away. So now, if I have something like this, let's say old accounts at position I dot ID. So this is something we just discussed, right? Versus if I say old accounts I dot ID dot twin versus old, okay, old is the keyword over here, accounts at position I dot ID dot deep twin. Okay, these three expressions all compile. They're all valid. Okay? However, the way you actually organize them is going to affect exactly what kind of copy is going to be made. Okay? Let me just make it very clear. Okay? Let's say over here, you have accounts over here. Temporarily, let's say I is simply just 1. Okay? Let's say we have an account array over here, and that's position 1. It's simply pointing to an array over here, account objects. So there's account objects with ID, which is also pointing to a string, let's say Jim. Okay, that's a setup. Okay, now let's talk about exactly what will be cached in each of the cases. Okay, case number 1, I'll use green. case number 1 over here, we know that this expression over here is associated with the old. So what we will do is something like this. I will say old, I will say accounts ID is assigned to simply just accounts at position ID. Just copy verbatim. This expression over here is copied verbatim to the right-hand side of the assignments, right? That's the pattern, okay? So now, what would that be? Well, that basically means you can think about old accounts at position ID is just going to point to the same string. That's a copy over there. So this copy is implicitly made for you, okay? So that you can use that in the post condition. Okay, let's look at the second one. The second one there, let's say I use pink over here. The second one here, the whole thing is associated with the old expression, right? That means what we are doing for the caching is something like this. Let's say old accounts at position ID, and then T for twin. It's assigned to, okay, we just got accounts ID dot twin. Okay, so what we're doing over here is basically we're just making a shallow copy of the string, right? Okay, what we have is basically old accounts ID twin. So now it should point to, rather than alias to this, it's basically just pointing to Jim over here, just like that. Okay. Well, in this case, maybe you wouldn't see so much difference for the shallow copy and deep copy, but you kind of see the idea. Depending on exactly how you write after the old expression there, the pattern for the cache, the value is always the same. Just the assignments and also the expression verbatim. So how you write the expression affects the way copies will be made. Okay, it can be a reference copy, it can be a shallow copy, it can be a deep copy, and we'll see exactly this after talking about the old expression. We'll see some bank example in complete details. Okay, let's go a little bit back over there. Okay, so now having that in mind, so now a question for you. Okay, let's have a look at this example over here. Okay, the third one. So now, what exactly will be cached before the body of implementation executed? Yes. The reference to the ID. So okay, are we going to cache the string ID, or are we going to cache something else? String ID. Okay, that's one answer. Anything else? I'm talking about this example over here.
We're going to cache the object at I.
The object at I, the account object at I. Okay, so the parenthesis over here is really the key. Okay, parenthesis simply say apply the old expression only within this particular parenthesis. Okay, so now you can see that the parenthesis over here, starting from here, ending over here. That's really crucial. Parenthesis might be your friend for lab number 2 when you write the contracts. Okay. So now let's have a look at that. So that means this is the expression we'd like to cache, only up to here. Okay? And in this case, what specifically will be cached? Let's just write it out, and then I'll try to visualize that for you. So what we have over here is, let me use green. So now we have old accounts I, only that, right? Is assigned to accounts at position I. That's all we are caching, because the old keyword is only applying to this particular expression because of the parenthesis. So now that means what's happening over here. Again, let's assume I is just 1. Let's assume. So what we're really doing here is we have old accounts at position I is just pointing to the same account objects, just like that. Okay, that's what will be cached. Okay. Let's have a look at another example here. What about the orange one over here? So now what will be cached? Entire, right? Good, now you learn it. That's good. Okay, you can see that according to the way we parenthesize the expression here, you start from here, ends over here. That means the accounts, which is in the array, is the thing we would like to cache, right? So now if you try to say that, okay, let me just write it out. What will be cached is something like this. So old accounts is assigned to just accounts. So that means you have old accounts that's pointing to just the same array. Okay? So now, whenever you write a postcondition with O expression, whatever you write with the O keyword here, that's kind of the consequence you got to think about. Sometimes you might be okay with just a reference copy. Sometimes you may need a shallow copy, or in the extreme case, you might need a deep copy. Okay? Let's do one more. What about this? Wow. What are we doing here? What are you copying here? Well, it seems like we're copying something that's even bigger than the array, right? Well, what's current simply means this in Java. Since we're assuming that we are in the bank account class, that means you're copying the whole bank account objects by using a reference copy, okay? So let me just write it down, okay? That's something I haven't really drawn in my picture, but I'll draw it for you, okay? Just for completion. So now over here, we got old current over here is assigned to just current. Okay, what is current? You can think about current, let me just complete the picture here. Let's say current is more like a bank account class. Current is basically just a BA for bank accounts, and bank accounts simply got an attribute called accounts, and that is pointing to this particular array. Okay, so now when we try to do this particular copy here, OC, old account, it's just pointing to this current, right? We're just at different level of copy. Guys, are we okay? Yes, question. Green and orange, let's see. The green and orange, yes, green and orange are both reference copy, you're right? But somehow it's a reference copy of different objects, right? For the green, it's actually copying the reference for an account. For the orange, it's copying the reference for an array. And even for the pink, it's copying the reference for an bank account. Okay? Yes? Yeah.
If the bank account class is an extended class,
Yes.
will it copy
Good question. It's a very good question. So now, the way I draw it, I simply assume the bank account class is simply reference type. That's why I simply draw this particular reference over here. So basically what you're asking is, what if the bank account, for some design decision we are making, we make it expanded? In that case, of course, you're going to copy everything, right? Yeah, true. That's true. Yeah. But I would say for lab number 2, you don't have to worry too much about expanded. We focus on reference type to begin with. That's more common in the object-oriented programming. Yes? I'll say it again. It's the memory address because, yeah, true. But we'll see more comparison. Just bear with me. We'll see even more, okay? So now I think this slide here, even though it seems a bit boring, but I think the main message over here is the way you write your old expression is going to affect what's going to be compared in the postcondition at the runtime. Because whatever you write, IFO will simply copy them verbatim before the body implementation is executed at the runtime and cache that for you and use that value when you do the comparison. Okay? So now what I hope to get into, I'm going to show you, I forgot, either 4 or 5 different versions for bank account, especially how you write the postcondition. It turns out you have to use a deep copy, deep twin in the postcondition to be 100% safe. Okay, we're going to learn that. Okay. Okay, so that's exactly what I just talked about. Okay, the same. Okay, you can just go over that quickly after the class. Okay. So now, when are the contracts complete? And we are slightly moving towards about writing complete contracts. Okay. So now let's just go over some slides and then we'll see one case study together. Okay, it's quite a big one. And then I also make the source code available to you. I'll do it after class today. Okay. So now for the postcondition, basically here's a principle. In the postcondition, because it's more like an obligation for the supplier to guarantee to the clients. From the client's point of view, I would rather to say every public attributes, I want to have some constraint to say what the supplier should do. Okay, that's kind of the principle. Okay, for every attribute. So now, the tricky thing is really composite type. Simple type like a balance, like an integer, is very easy. I can say balance equals O balance minus amount. That's easy to have. But what if you have array, or you have linked list, or you have binary search tree? how do you specify a postcondition that can completely constrain the supplier how they should modify the data structure? That's really what we have to pay attention to. Okay, let me give you some principle over here. Okay, for example, array, linked list, or any tree composite structured, okay? Versus integer or Boolean. These are really, really straightforward to have. Okay, let's see. Rule of thumb. So basically, every time if you want to write a postcondition for your array or linked list, okay, this is the thing. Number one, you want to say the intended change that you want to do is already there. Remember, there was one postcondition we wrote together last lecture or the previous 2 lectures. We said I want to change only a particular position of the array, how do I write the 2 postcondition? I want to say, number one, at that particular index, the value is really changed. And number 2, I want to make sure all the rest of the array remains unchanged. That's exactly the idea over here. Okay, so number 1, the intended change is present. This one is typically easy to write, and you don't have to use any across universal quantification usually. Okay. Number 2 is really the critical part, and this is why I show you all the background information about copies. That's why we're going to see it. Okay, the rest of the structure is unchanged. That's the tricky part. Okay. Okay, the second concept is usually harder to write because reference aliasing, right? You might get aliasing structure throughout. So now you want to decide when you write your postcondition, should you write reference copy version, shallow copy version, or deep copy version? A different version you write is going to trigger a different ways of catching the value in the pre-states. That's why you had to understand exactly how they work. But we're going to go over one example together. And iterable structure. We're going to talk about iterable, some iterator pattern, which you will use. You will use them in the lab 2. But for lab number 3, you have to implement iterator pattern yourself, which we'll talk about, don't worry. I'll try to cover that before your lab 3. Okay? Okay, so now let's talk about an example. Okay? We talk about a very simple example. We got bank account and just an array of account, basically. Okay? Let's see. Let's just go over some code very quickly. The code is very simple, but I just go over that. And then we'll present to you different versions of writing the postcondition. And then we're going to criticize to see why all the previous version, before the final version, all actually are not complete, basically. Okay, they're all going to suffer from some drawback. Okay, let's say we have an account class over here. And then we simply redefine the is equal. Okay, so you have done something like that for lab 1. We want to redefine or override the is equal feature. And then we have a constructor here called make. And then let's say we only got 2 attributes for the account. We got owner, we got balance. Okay? Owner and balance for the account. And then that's how we initialize an object for account. Okay, very easy account class. Now the more interesting bit is in this, oh, not yet. Okay. We got deposit over here. Deposit is easy. We simply just do an amount. Of course, you can put a precondition here. The amount should be positive. You can do that. Let's ignore that just for now. Okay? And this is very easy postcondition you can write. Okay? We'll talk about something that's much more sophisticated than that. Okay? And also we got is equal here. For the is equal, we simply make sure the owner is the same and also the balance is the same. Okay? One more thing to mention here quickly. Because balance over here is of type integer. As I mentioned before, integer is expanded class. So over here, when you use equal sign over here, it is going to compare the contents, right? Not just the reference, just a minor detail for you. Okay? Now, account class is not that exciting. What's really exciting is the bank class. Okay? The bank class over here, let's see this. Okay, we got a bank class also with a constructor called make. And then we have an array of accounts. And then we have a constructor which is just going to make an empty account. Okay? Only one attribute to worry about for the account class. For the bank class. Okay, for the bank. And then let's say we have a query to say given the name of the owner, some owner, for example, I want to see what's the account objects for the owner called Jim, for example, if Jim exists. Okay? And now let's practice some precondition for you. Okay? How would you write a precondition over here? Let's say we require that if you want to call this query here, the owner must be an existing owner. Okay? How do we do that? Yes. Let's say we don't have has. Let's say we don't. Of course, you can define that. Let's say for this particular question, let's say we don't. What I want you to have is a cross notation. Now, what should we got three options here. We got across all, we got across sum, we also got across loop. Okay, should you use across loop, by the way? No, right? If you look at my common errors slides, I tell you, number one, don't use across loop in the contracts. Okay? Now, for across sum or across all? Well, across all should also be able to do the purpose, right? Okay? Actually, you remember you can rewrite any existential quantification as universal quantification. I'm going to show you here, okay, for your information. Okay? Let me just mention some logical rule for you very quickly, and then we'll go for that particular one. Okay? Now, let's just let me use one example to show you. Okay, let's say this. For every students, for every S, such that S is a member of, let's say, EECS 3311, okay? It is the case that S dot pass is true. Hopefully that will be the case, right? So now, that's the universal quantification. How do I rewrite it in a way that's going to use existential quantification? Well, yes. Exactly, double negation over here, right? Okay, intuitively, if everybody passed, that means there's not a single person who fell, right? So this is equivalent to, it is not the case that there exist students in EECS 3311 such that it is not the case that S dot pass is the case, right? Okay, notice the double negation over here. So this is mainly a response back to your answer. You thought you would just use a cross sum. Yes, that's actually easier to write, but you can definitely use across all if you want to. But I'll show you both versions, okay? Yes? It's a very good question. The question was, if you use a cross sum, let's say you're crossing, let's say, an array of 1 million items. If I already get to the first item that's already giving me true, is it going to stop? You know, I think it should, but it is more up to the optimization by the compiler, but we don't have to worry. Hopefully they did, I hope, right? Yes. Okay, that's some logical rule to mention to you. Of course, you can do the same to rewrite the existential quantification as universal quantification. Okay, so now let me show you this, and then we'll try to do some exercise together. Now, let's say this. If I say across I want to say that the input string must be an owner's name that exists in the bank class. So I can say across the accounts as ACC. So now ACC is a pointer, is a cursor to account objects. That is why I can see ACC, the item, the owner, is the same as N. So I'm using across sum. Okay, let's now practice this. Okay, let me just write down what I have over here. So what I have here is across accounts as ACC, and I say sum. And over here, ACC, the item, which is going to give me an account object, dot, I believe ID over here, right? The owner, okay, the owner has the same name as the N, and the N is simply the input argument over here, right? Okay, now, how do we rewrite this guy over here using across sum? Across all, sorry. That would just be logically equivalence. Well, we're going to use some double negation, right? Okay. Basically, we want to say it is not the case that all the accounts in the bank right now don't have that particular owner. Okay. That's basically what we're going to do. Okay, I'm going to write it here. It is not the case. Okay. I'll write it like that. And then I would say across accounts. Okay, not is also a keyword. S, ACC, and then I have all over here, and then also N. And then I can say actually, make it a little bit more explicit for you. You can say not the case, ACC.item.owner, the same as N. Okay, that's how you write it. So both ways are equivalents. Okay, are we okay with this? Okay. Yeah, don't be afraid to apply logic that you learned in the previous course. It's really useful. We're using it in a very practical way. Okay. Okay, so now that's good. So that's about the accounts off. So basically, whatever whatever owner name you give, we're going to return the associated account objects. It's going to be useful at some point. Okay, we'll see that. And then we're going to do, let's ignore the implementation. I'm sure you know how to implement that. And then let's say the result. Again, for every query that returns something, you can use the result to refer to the return value. I'm saying whatever I return, that result, that owner should be the same name that I'm looking for. Okay, it's a very obvious postcondition to have. Okay, now also we got to add. Okay, now for the add over here, okay, I will just show it to you. It's done in a similar way. So now the precondition for add, we want to make sure there's no duplicates of the account with the owner. So now we want to say, well, we want to make sure the owner you're adding the account for should not exist already. Okay, a similar issue. So not existing. Okay, you can just go through the precondition over here by yourself. Okay, now I'm using across all rather than across some. As an exercise for you, convert this into across some. Okay, that's what exercise I'll give to you. Okay, and okay, you can also declare things like that. And then, okay, I'll just show you the basically the implementation anyway, but just using force for the array. Okay, guys, are we okay so far? Okay, I'm just showing you the bank class where we got an array of accounts. So now what we want to do is to see something interesting. Okay, hopefully we're there. The roadmap for the illustration is as follows. Given that we have an account class, we also got a bank class. Okay, we're going to do the following. We're going to consider this particular feature in the bank class. Okay, remember in the account class we got a deposit. Okay, but now in the bank class we also have a deposit feature, and over there we're just going to take an extra input. We're going to say given the owner name for the accounts, we want to go to that particular owner's account, deposit this particular amount into it. Okay, that's what the feature will do. And now we want to worry about how to write complete postcondition for this particular feature. And you can see the complication over here because now we are talking about the bank class. And the bank class have an array of accounts. We want to make sure the array is manipulated in just the right way. That's why we need complete contracts. Okay? For example, let's say we got only 2 accounts in the array. We got Steve, we got Bill. Okay? If I only want to deposit into Steve's account, not only that I want to make sure Steve's account is changed, but also Bill's account stays untouched. Okay, so these are the 2 things I have to do. Okay, but that's exactly the illustration. Okay, and we're going to see 5 versions. Okay, starting from wrong version number 1, wrong version number 2. Eventually, we get to the version that's right. Okay, but not only that, you want to know which version to use for your lab 2, but also you want to understand why the other 4 versions are not appropriate. Because we don't necessarily ask you to write IFO code in the exam. We might give you the wrong version as IFO code and ask you to explain why it is wrong. That's actually more important. That's actually really assessing your knowledge about the smart contract. Okay, so now the version number 1, we're going to show you that we simply don't use any across. We simply just use, we're going to use the, we're assuming that, let's say if the implementation is okay, implementation for deposit office is simply correct. And then we simply give you some incomplete contract. I'll show you what I mean by incomplete contracts. And then, even though nothing will go wrong at the runtime, but it's simply not satisfactory. Okay? In version number 2, we'll still keep the incomplete contracts over there, but we're going to modify the implementation so that it is wrong. However, the wrong implementation is not going to make the incomplete contracts unhappy. That's also not right. Because as we said before, if the implementation is wrong, there's got to be some post-condition violation occurring at the runtime. If there's no, that means something wrong. Version number 3, we're going to keep the same wrong implementation there, and then we want to try to gradually improve the postcondition. The first attempt for the complete postcondition, we're going to use a reference copy in the old expression. It turns out reference copy is not going to be helpful. Okay? What about shallow copy? Well, shallow copy also is not going to be helpful in this case because the change we are trying to make is beyond the first level. That means only deep copy, the final version, is going to be the one. Okay? Let me just tell you what the conclusion is by the end of the lecture or by the end of Wednesday. If you want to write a contract that's guaranteed to actually work, always use deep copy. There's a catch to it. It's extremely inefficient. If you got 1 million items in your binary search tree, you're gonna deep copy the 1 million items. So your code simply might just stop working because too many things to copy, right? Of course, you want to judge to see if you really had to use deep copy, you use it. If you don't have to, don't use it, okay? So these are the 5 versions we're gonna talk about, okay? So now let's set up the context, and then we talk about hopefully at least the first 2 or 3 versions, okay? We still have maybe about 15 minutes. We'll see how much we can do, okay? Now, let's assume this particular setup, okay? Let's say we have a bank, okay? It's called B, bank, and then we got an accounts array, and then B, the account is referring to an array of size 2. Actually, for some reason, the indices start with 0. Okay, doesn't matter, we'll just leave with that. And then let's say initially, we got 2 accounts. Let's say we got the account for Bill, we got an account for Steve, okay? Let's say initially the balance is simply just 0, okay? A very simple setup. And then we're gonna see how we can define the deposit of feature or command so that we can live through the various versions and see which one is appropriate and which one is inappropriate, okay? Let's see. Okay, version 1. It's got incomplete contracts but correct implementation. Okay, let me see if I have anything on the iPad. Yes, I do. Let me show you some code over here, and then we'll move on to iPad, okay? Okay, so now let's say we got, let's only go over again the version 1 code in complete details. All the other 4 versions look more or less the same, more or less, just a few line changes, okay? Let's say we got this deposit on, and then I call it V1. So when I make the source code available to you, you'll see exactly these features over there. You can try them out, okay? So deposit on, version number 1, okay? So now we got the require over here to make sure if you want to deposit to Steve, you better make sure Steve is a valid owner, okay? That's precondition is not the issue here. And then we simply do a loop over here. We simply just try to find out if the current iteration finds out the owner is the one we're looking for, we'll simply deposit on that particular account, right? Very straightforward implementation. You can take my word, this particular implementation is correct, okay? And then what about ensure? Okay, let's say we do some contracts over here and see why it is incomplete, okay? I want your help to explain to me. Let's say we ensure, number 1, the number of accounts in the bank stays unchanged, which means we don't really add any new accounts to the bank. Still remains to be 2 accounts in the bank, okay? That's the first one. And the second one, we want to make sure, remember the accounts of feature that we just talked about? Let's say, for example, let's say we say deposit on V1. Let's say Steve, and then let's say $100, okay? So what I'm doing here, account of Steve, the balance, the new balance for Steve, must be equal to old account of the balance plus A, right? The old version for Steve plus A. Let's look at this particular one a little more detail, okay? Especially the second one, okay? Let's look at the second one here. So now we can see account of over here. And now my question for you, again, we see the old keyword. Based on what we just learned, which expression is going to be cached before the body of implementation is executed? Which expression? Is it going to be an account? Is it going to be a string? Or is it going to be something else? Yes?
It should be an integer in the balance.
Exactly, right? Because over here, you can see that the old expression, the old keyword here applies to basically this part. That means this part is going to be cached, okay? So now this is going to be cached in the pre-states. Okay, and then once we get it, that means we're going to save that value there before the deposit off is executed, and then try to do it. Try to compare that with the new value. Okay, now I want your help to tell me why this particular contract is not good. Okay, I know you guys must be very clear about what the issue. Let me just skip you guys, right? Not like I don't like you, but I want to try somebody else. Okay. Anyone from this side want to try? You know what? Either you try it now or you try it in the exam. I shouldn't terrify you. You know, it's okay. Yeah. Just try. Give it a try. So now, okay, if I ask you to explain to me why this particular postcondition here is not complete, I want you to give me one scenario where the postcondition is not going to be violated even though the implementation is wrong. Okay, let me help you a little bit here. Let me help you. What I can do over here is, let me say I want to do B dot, oh actually I do have that, sorry, I forgot. Okay, can you look at this line here? Here. B dot deposit Steve and 100, right? So now, good. So now, can you imagine a very evil supplier? At the moment, the supplier is pretty good. They did the right thing. Can you imagine something the supplier might do wrongly so that its postcondition might still be violated? Yeah.
They might deposit money to another account that isn't Steve.
Yeah, exactly. Okay, let's try that. Okay. Yeah, I'm pretty sure that's what you guys were thinking about, right? Okay, good. Good. I knew it. Good. Okay, now let's give it a try. Let's say over here, that's actually what version 2 is going to show you about. Let me just give you a little bit preview. Okay, we know that from this particular correct implementation, if you want to deposit 100 into Steve, that means Steve's account over here, rather than 0, it should be 100. This is so far is the correct behavior. What if the supplier deposit 1 million also to Bill, right? Now, is the current contract going to complain? Well, let's see. Number one, is this particular postcondition going to be true? Yeah, because, well, you can see we didn't modify the size of the array, so this is going to be fine. What about here? Well, you can see that over here, the account of N over here is simply just Steve. The current balance for Steve is 100. What about the old version for Steve's account? 0, right? Assuming that that's already cashed. 0 plus, and we are depositing 100. And this will be just true. So that means this postcondition here is also fine. But we are done. Nothing is constraining the rest of the accounts array. Nothing. So this postcondition here, even though it's constraining something useful, but it hasn't constrained everything you should really constrain on. Okay? So what's really wrong is this part over here is not really cached. This part here is not caught. That's the problem. Okay, that's really why this particular postcondition is incomplete. So do expect some question on the exam like this. I might give you something like this, maybe a different feature, and then I'll give you some postconditions to start with. And then I will ask you to judge the following. Judge to me whether the postcondition we have so far has any logical error. If it has no logical error, is it logically complete? If it is, give me some example. Right? That's kind of the thing you want to really get used to. Okay? All right. Let's now go to version number 2. So now if we go to version number 2, let me just go over some slide with you. Okay. Yeah, actually you can just go over the code over here. It's very easy to follow. Okay. Okay, so now for version number 1, everything is just fine. Simply because the contract is incomplete. Even if you do something evil, you just cannot tell. That's actually, so having everything, having a green bar over here doesn't mean too much. Well, you can easily get a green bar for your lab 1, right? You can just set all your student tests to be true. I'm not sure if you noticed that. I hope you didn't do it, right? We wouldn't punish you for that, but you know, you're kind of lying to yourself. Hopefully you didn't do that, right? Yeah. You might do that in the beginning, but not at the end. Right? Good. Version number 2. Okay, version number 2 is exactly what we anticipated. So what we'll do over here, and let's show version number 2 very quickly. Let's say we do the same loop as before, but now the supplier somehow simply try to modify another account and deposit something, the same amount, to that particular person. Okay, so now not only to Steve, but also to Bill for the same amount. That is absolutely wrong. And we just learned that this is going to still make the post condition happy, simply because the post condition is not complete. Okay, that's version 2. Okay, so now if you try to run version 2 test, it's still going to, it's just going to tell you that over here you can see some check over here. So calling this particular feature over here is actually not going to give you any post condition violation. But when we try to see outside this particular call, we'll see that the balance is not as expected. So there's something wrong. Okay, something wrong, but there's no post condition violation. Okay. Questions? The ensure? No, actually, no. The version number 2 is like this. Version number 2, we still have the incomplete contracts, the post condition, but the implementation itself is wrong. But we don't have any post condition violation. That's a problem. Yeah. Okay. Now, guys, let's maybe just 2 or 3 minutes. Let's have a quick look on version number 3. And then once we go a little bit with version number 3, we can finish the other 2 quite quickly on Wednesday. Okay, so we can move on to other things. And you'll be ready to do lab 2. Okay. By the way, lab 2 is due next Monday. You know that, right? Okay. The 2 weeks long period of lab assignment is gone. Not going to happen anymore. Okay. Please manage your time well. Okay. All right. So now let's look at version number 3. Now, what I want to show you is like this. Let's try to at least understand what's going on for the contract I'm writing here. At least we'll understand that before I let you go today. Okay? So now basically everything up to now is the same as version number 2. So we have a very evil supplier over here, which also deposit to the other account. Okay? And now we also got these contracts over here, which we know is incomplete. So now we attempt to add some extra post condition to make it complete, but we want to know whether that will work or not. So let's say we got introduced another tagged post condition over here. Let's call it others unchanged. Okay? And now let's read this post condition together with you, and then we'll continue on Wednesday. Give me a 1 or 2 minutes. Okay, like that. Can you read it just for now before I switch to iPad? Okay? And see what we're doing here. And since we got an old keyword over here, I want you to also think about exactly what value will be cached in the pre-states. Okay, so now you should have enough knowledge ground to think about such issue. Okay? Okay, so now let's think about it. Okay, you can see we also got implies over here, right? Okay, let's go to version number 3 and over here, and let's talk about it. Okay, version number 3. So now let me just, all I want to do in just 1 or 2 minutes is only to talk about the logic for this particular post condition over here. Okay? So now, first of all, if you look at this particular expression over here, what value will be cached in the pre-states? Accounts object, right? Are we going to cache the bank or the accounts? Accounts, right? The array. Okay, very good. You can see that. Exactly this particular value will be cached. Very good. So now, let's try to understand this particular logic over here. So now, let's see what we're doing here. And let me read it out to you. We're saying that if the current account we're looking at, the owner, is not the same as the one, for example, we are changing Steve, right? If the current owner we're looking at is not Steve, that means it should not be the account we want to modify. That means their account should be the same as the old version. You see what I mean? Okay? You know what? I intend to pause over here, okay? I really want you to think a little bit more about this particular logic. Especially, I want you to link. Let me just go back there and then I'll let you go, okay? Think a little bit more about the logic for this one. Let me, 30 seconds, please. Okay, 30 seconds. I want you to look at this particular iPad over here specifically. Okay, give me 1 moment. If I can get there. Okay, this one here. I want you to look at this particular nodes that we talked about how you can specify it using implies. You want to make sure the rest of the array is unmodified. Okay, the same logic over here. Okay, we'll continue from here on Wednesday.